Okay, here we are. Last segment of the day. We are doing probability. Same format. I'll give you a shot and then I will show you how to do it. Let's start with problem number 9. So like normal, I'll give you a look just to make sure we're doing the same problem. The questions are posted with you anyway. It says the distribution of a monthly rent for a one-bedroom apartment in a city is approximately normal, with a mean of 936 and a standard deviation of 61. A graduate student is looking for a one-bedroom apartment and wants to pay no more than $800 in monthly rent. Of the following, which is the best estimate of a percent of one-bedroom apartments in the city with a monthly rent at $800? So you will freeze for a second, boom, freeze, and then boom, I'm back. Now that you've frozen and had a chance to do it. Okay, whenever I'm doing a normal model question, I am going to get on the board z equals y minus mu over sigma. And the mean in this was given at 936, and the standard deviation was 61, and they were looking at 800. So let me get my calculator out. 800 minus 936 divided by 61 is a z. Remember, this is z equal to negative 2.22. Now, they wanted to pay no more than that. So think of the normal model like this. They want this out here. So the other z-score is negative 99. So if you get your calculator out, go to normal CDF and go to negative 99 and negative 2.22 and hit paste. I think you're going to see 1.3%, which is letter A. All right, one down. We're on the move. Question 12. Cancel this out. Question 12 says the random variable x is normally distributed with a mean of 5 and a standard deviation of 25. The random variable y is defined as y equals, let me write that on the board, y equals 2 plus 4x. And remember, the mean is 4, so you put on mean. The mean of x is 5, so you're going to have 4 times 5 plus 2, 22 for the mean. Now comes the only little trick in this problem is with the standard deviations. Remember, you did not add the constant, so it would be 4 times 25, but you would not add the 2. So it would just be 100. So the answer would be D, mean of 22, standard deviation of 100. 2 down. Next question, number 14. Number 14, it looks sort of like this. So if you want to pause for a second and attempt it yourself. It says a produce suppliers ships boxes to produce to individual customers. Oh, how timely. We got our little boxes out here on the doorstep, free produce boxes. The distribution of weights of shipped boxes is approximately normal, with mean 36 and standard deviation of 4. What expression represents the weights in pounds of the 75th percentile? Like I said, anything dealing with the normal model, I am doing this. And
good afternoon, everyone.
Filling in where I can.
Thank you, students and teachers, for attending.
We are having
Great Recovery Wednesday.
the announcements right now, so I will pause for a second.
On your way out this afternoon, we do remind you to please maintain distances of 3 feet with masks on, 6 feet with your mask off as you make your way to the buses. But on the bus, please be sure that you're masked for your full bus ride home. We will dismiss today as a full school. No need to have our staggered exit. So at this time, all students are dismissed. Thank you and have a great evening.
Boom. Announcements over, back at it. In this problem, I think the key is the 75th percentile. Obviously, there's no percentile rank up there with the formula, but we know Z can be a percent. You can convert it. So you go to inverse norm, put in 0.75, and I get 0.674. 0.674 equals y minus the mean of 36 divided by the standard deviation of 4. Multiply both sides by 4 to get rid of that, and then add the 36, and you get D, 0.67 times 4 plus 36. There's number 14. Number 22. Now 22 is a little, it's, you know, maybe a little hard, maybe not. We'll see. It says the faces of a four-sided fair die are numbered 1 through 4 respectively. For a certain game, the die is tossed and the number of that lands face down is recorded. The table below summarizes the points a player earns for the number that lands down. This is similar to those questions 3 through 8 we had in chapter 16. One was on kids, one was on carnival, one was on card games, things like that. That's what this is like. So a probability model tells you the number of points and tells you the probability of getting it. Okay, so let's go through all the potential outcomes. You could get 0 because if you look in the chart, there are 2 different ways you can get a 0. You can get a 1 and get a 0 and get a 3 and get a 0. So I did some figuring ahead of time and I saw a 1, 1, 2 1s give you a 0, 2 3s give you a 0, a 1 and a 3 gives you a 0, and a 3 and a 1 gives you a 0. Each one of those combinations is 0.25 times 0.25, which is 0.0625. And there are 4 combinations that work. So I multiply it by 4 and I get 0.25. So far, everyone but the last one. So the last one cannot be right. E is out. So we're still okay, A, B, C, D. We'll go as far as we need to get the right answer. Now, as far as the second one is concerned, to get 1 point, you could either have 1, 2, or 2, 1. 2, 2 gives you, no, we hold it. No, back up. 1, 2, or 2, 1. Both of those give you 1 point. 2, 3, or 3, 2 also gives you 1 point. So there are 4 combinations again of that same 0.0625. So 0.0625 times 4 gives us 0.25. So we've got rid of C is out of there now. They didn't have anything for 1 point. And B is out of there too. because you can get 1 point, 0, 1, 0, 0, 1, or 1, 0. So we are down to A or D. A or D. And you know what? I don't really need to go any further, because if you look, I know that I can get 4, can I? I can get 2 2s. I can go 4 twice, which would be 2 2s, which is 4 points. That factors out A. Therefore, the correct answer is D. All right, next is number 27, which looks something like this. 27. You can try it, pause the video and try it first, and then we'll go for it. It says a contestant's final winnings on a game show are determined by a random selection of a base amount and a possible multiplier. For the base amount, the contestant randomly selects one of 4 cards. Where 2 cards are 1,000, so I figured this out. Two cards, 2 of the 4 is 0.5, 50%. So 50% chance of winning 1,000, 1 out of 4, which is 25% chance of winning 2,000, and 1 out of 4, 25% chance of winning 5,000. After choosing the card, the contestant randomly selects one of 5 chips, where 3 chips are red and 2 chips are white. So 5 total chips. So 3 out of 5 is 60%, and 2 out of 5 is 40%. If the selected chip is red, the final contestant wins twice the amount. If the selection is white, he wins the base amount. What is the probability that a contestant's final winnings are exactly $2,000? All right, the way I looked at this is there was 2 ways to get to 2,000. One would be just winning the base amount, which is 2,000. Let's get some information up here. We have a 1/2 chance. We'll go with the percentages. A 0.5 chance of winning $1,000. A 0.25 chance of winning $2,000. And a 0.25 chance of winning $5,000. Now, these little chips, which are multipliers, the red is 3 out of 5, 0.6 red, and you're going to double it, so times 2, and 4.4 for white, and it stays the same. All right, there's some data for you up there. Now, I saw 2 ways to get to $2,000. You could multiply the 0.5 for winning 1,000 times the double, the red, 0.6. And that gives you 0.3. Then the other way you could win it is the standard way of 0.25, 2,000 times 0.4, and that gives you 0.1. And you add the 0.4 with the 0.3 with the point, you add the 0.3 with the 0.1, and you get 0.4, which is E, is the correct answer. Okay, we're getting there. We're getting there, slow but sure. Number 35. Carly commutes to work, and her commute time is dependent on the weather. When the weather is good, the distribution of her commute times is approximately normal, with a mean of 20 minutes and a standard deviation of 2 minutes. When the weather is not good, the distribution of her commute times is approximately normal, with a mean of 30 minutes and a standard deviation of 4 minutes. Suppose the probability that the weather will be good. Tomorrow is 90%. Which of the following is the closest to the probability that Carly's commute time tomorrow will be greater than 25%? All right. So remember, whenever I'm talking about a z-score or normal model, y minus mu sigma. Now, so we have good weather and we have bad weather. Let's start with the good. It said when the weather is good, approximately 30. So the mu is 30 and the standard deviation is 4. And I think 25 is the time for both of them. So there's when the weather is good. No, it isn't. That's wrong. It should be over here. This is when the weather is bad. Sorry. And we will erase. And when the weather is good, it's 20 and 2. So 25 minus 20 divided by 2. So let's get z-scores for both. That is 5, 5.5, 2.5. And over here, negative 1.25. Now they're both greater than. So here, this one, think of this out here, so it isn't going to be very much. And I'll get my calculator out and I'll do normal CDF. .5 and 99. And I get 0.006. So that's for the first one. And then the second one, think of it this way, negative 1.25, and you got a whole lot more because you're going all the way up to 99. So I go to normal CDF, and I go negative 1.25, 99. Got to do it again. Negative 1.25, 99. And I get 0.894. Okay, I'm not done though, because it said there was a 90% chance that the weather is good. So I got to multiply that 0.006 times 0.9. And I get 0.0054. And then over here, if there's a 90% chance the weather is good, there has to be a 10% chance that the weather is bad. So 0.894 times 0.1 is 0.0894. And I add the two together, 0.0054 plus 0.0894. And I'm hoping to get one of the answers, 0.0948, and that is awfully close to C, which is your correct answer, 0.0950. Okay, just a little rounding. Okay, on that one, that's number 35. The last question of the day for me. I think I've done like, I don't know, 25 or 30 of them. Quite a few. Let's put this on the board. This is a Venn diagram. Venn diagram. Number 40, by the way, on you. Number 40, so we make sure we're looking at the same one. It says, SC Electric Company has bid on 2 electrical wiring jobs. So let's get a nice Venn diagram up there. And it says the first job, event A, is 0.75 probability probably be awarded. The second job is 0.5, and both jobs is 0.375. So this is like the problem we did, like going to Mexico or Canada, that type of deal. So we got to figure out what is the probability of winning only the job A, which would be 0.75 minus 0.375 is 0.375. And then only job B, 0.5 minus 0.375 is 0.125. Now, if I wanted to finish out the Venn diagram, 0.375 plus 0.375 plus 0.125 is 0.875. So that means 0.125 is the percent chance that you didn't get either job. Okay, now that we've got the Venn diagram, hopefully the question will be pretty easy. All right, it says they have 5 options here. And of the 5 options, it talks about mutually exclusive. Now, mutually exclusive means it's one or the other, but not both. The fact that these 2 events are connected, the circles are connected, it is not mutually exclusive. Therefore, letter A and letter B are out. Now we're down to C, D, and E. Now, C says event A are not mutually exclusive. We like now the test of independence. Now, this was kind of a weird formula that said this. The probability of B is equal to the probability of B given A. So the probability of B was 0.5, the whole thing, probability of B. Probability of B given A was 0.75. B given A was 0.375. 0.375 over 0.75 is equal to 0.5. Therefore, they are independent. Boom. C is the correct answer. Look at that. C is the correct answer. I have done, or if you've done them with me, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. Geez, I thought there were even more than that. But 23 multiple choice questions, all explained out. Now, I am these questions that I've done today have come off the last time they released questions from an old exam. These are the newest and hottest questions. So they aren't fake. They're good questions. All right. So we will see you on Friday. See you later. Bye.